By now you should be familiar with what logs are from last week's lesson. And now we're going to get into what are called the properties of logs. And we have three properties that we're going to work with. We have the product, the quotient, and the power property. So let's start in with the product property. Remember, product means multiplication. And so our product property says that the log base b of m times n is equivalent to the log base b of m plus the log base b of n. So these are equivalent, so it goes both ways. If I have log base b of m times n, I can rewrite it as log of m plus log of n. Or if I'm given log of m plus log of n, I can rewrite it as log of m times n. So let's look at this in a couple of examples. Let's start with number 1 here. I have log base 2 of 7 plus log base 2 of 4. So I can rewrite this as m times n, where m would be 7 and n would be 4. So I have log base 2 of 7 times 4. Now 7 times 4 is 28, so this is log base 2 of 28. Now another thing that's important to know is these properties only are true when my logs have the same base. So if I had log base 3 of 7 plus log base 2 of 4, I could not combine them this way, only when they have the same base. All right, let's take a look at number 3. Log base 4 of 2x plus log base 4 of 4x squared. They have the same base, so I know I can use my properties. And this is going to be log base 4 of 2x times 4x squared. And now you'll have to remember back to when we were working with our power rules. And so remember, I multiply my coefficients, so 2 times 4 is 8. And then for my x's, I'm going to add their exponents, and that's going to give me x cubed. So that's number 3. So that's going from adding to the multiplication. Let's look at it the other way around. So log base 6, that's the same thing as log of, say, 2 times 3. And if I have the log of 2 times 3, I can rewrite that as the log of 2 plus the log of 3. So we're doing it the other way around here now. Let's look at number 6. Log base 2 of 5x. That's the same thing as log base 2 of 5 times x. So I can rewrite that as log base 2 of 5 plus log base 2 of x. So that is our product property. We are now going to move on to our quotient property. And so if I have log base b of m divided by n, that is equivalent to log base b of m minus log base b of n. And just like multiplication, it goes both ways. If I'm given log base b of m minus log base b of n, I can rewrite it as log base b of m over n and vice versa. So let's look at number 7 here. Log base 3 of 24 minus log base 3 of 8. I have the same base, so I can use my quotient property, and that'll be log base 3 of 24 divided by 8. Well, what is 24 divided by 8? It is 3. So the log base 3 of 3 is this simplified logarithm. Let's take a look at number 9. Log base 4 of x squared minus log base 4 of x to the 9th minus log base 4 of x squared. I have the same base, so I can rewrite log base 4 x to the 9 divided by x squared. Now remember, from our power rules, when I'm dividing like terms, I subtract their exponents. So this simplified is going to be log base 4 of x to the 7th power. So that's going from subtraction to quotient. What if I'm given it the other way around? Well, log base 8 of 4, I could say that's the same thing as log base 8 of 8 divided by 2. And I can rewrite that as log base 8 of 8 minus log base 8 of 2. Let's look at number 12 here. I have log of m over 7, so I can rewrite that as log of m minus log of 7. So that is our quotient property. All right, we have one more now. We have our power property to look at. And our power property says that if I have log base b of n to the n power, that is the same thing as n times log base b of m. And that sounds trickier than it really is. So let's work an example. So I have 5 times log base 4 of 2. So let's label this. This number on the outside is my n, my base is b, and 2 is my m. So I'm going to put this back into that property form that is right here in my notes. So log base b, here b is 4, of m is 2, to the n power, and we said n was 5. So this is log base 4 of 2 to the 5th power. Not too bad. But let's take a look at number 15. Again, let's label again. This number on the outside is our n. Remember, I don't have a base here, so I assume it's 10. So b would be 10. And then m is our 8. So if I'm going to rewrite this, I'm going to have log, but we don't have to write it because it's 10, of m. M here is 8. And my exponent is to the 1/3 power. And remember, when I have something to the 1/3 power, that's the same thing as the cubed root. So this is the log of the cubed root of 8. Well, what is the cubed root of 8? The cubed root of 8 is 2. So this is log of 2. Okay, now let's work it the other way. Let's look at number 16. I have log base 2 of 8 to the 7th power. 2 is my b, 8 is my m, 7 is m. So if I'm going to rewrite this, I'm going to have n on the outside, so 7 times log base 2 of m is 8. All right, let's do one more. Let's do number 18. Log base 7, that's my b, w is my m, and if I have the square root here, my exponent n is going to be 1/2. Remember, I can rewrite square root as 1/2 power. So if I'm putting this in my form, my n goes on the outside, 1/2 log base 7 of w. And there you have it. Those are our 3 properties of logarithms.